Hi students, have a great day. Today we are going to see the frustum of a right circular cone. So this is a 13.4 exercise. I have completed 13.1, 2 and 3. So this is the last exercise of this chapter. Okay, so this is frustum of a right circular cone. So what is a right circular cone? So the cone of the shape. Okay, so this is a cone. So what is a frustum? If I cut this cone parallel to base, so this is the base of the cone. If I cut this cone parallel to base, then the remaining part left out is called the frustum. So like this. Okay, so this part is the left out part, remaining part. Okay, so this I have cut and removed, and this remaining part is called as the frustum. Okay, so how can we can find the volume of the frustum? We can find the surface area and we can find the total surface area. Okay, so how this can be done? This is the whole cone. Okay, so this is the cone 1. So this is, suppose if this is 2, if I subtract volume of 1 minus volume of 2, you will get volume of 3. So like this the volume is derived from the cone. Okay, so volume of 3 is nothing but frustum, getting whole cone from the big cone. If I remove this volume, the top volume, then I will get the bottom volume, which is the frustum. So the derivations are there, but it's not out of the scope of your 10th standard. If required, you can study that, and if you want, you can send me in the comment section so that I can explain you the derivation also. So for time being, for right now, in the scope of the 10th standard, you can remember these formulas. This is the formula for volume of frustum. This is curved surface area. Curved surface area means only the surrounding area. So this surface area, this surface, this surface area. Total surface area means including the top area, area, and bottom area also. That means top area is nothing but a circle and bottom area is also a circle. So this two, if it is included, then it means the total surface area of the frustum. So L is the slant height. So if this is the frustum, it will be having two radius. This is radius 1 and this is radius 2, and this will be the height and this will be the slant height. Okay, so this L. So this L you can find out using square root of h2 plus r1, the difference between the radius whole square. This is the slant height. Okay, so now coming to the exercise. First question is, as usual, you have to take pi is equal to 22 by 7 only if it is, unless otherwise stated. Okay, so all time we will take pi is equal to 22 by 7. So the first question is, a drinking glass is in the shape of a frustum. The glass is in the shape of a frustum. Okay, so of a cone of height 14 centimeter. The height here is 14 centimeter. The diameters of its circular ends. So this will be 2. Since it is small, this will be 4. The diameter of the circular, this thing is given as 2 and 4. So that means this radius is 1 centimeter and this radius is 2 centimeter. Find the capacity of the glass. Capacity is nothing but volume. So volume of glass means it's a volume of frustum. So volume of frustum formula is 1 by 3 pi h into r1 square plus r2 square plus r1 into r2. Okay, so 1 by 3 pi, you have to substitute 22 by 7 and h is given as 14. r1 square is 1 square and r2 square is 2 square. See here, the radius is 1 square and 2 square plus r1 into r2. Okay, so you can cancel this. So now 1 by 3 into 22 into, this will come to 1 plus 4, 5, 5 plus 2, 7. Okay, and here one more 2 is here. So into this 2, this 2. Okay, so this is the answer. So you will get 308 by 3, which is equal to 102.66 centimeter cube. Write this. Okay, it is given in centimeter and we are finding the volume, so it will be cube. That's it. Very easy sum. Only thing is you have to remember the formulas. Okay, so next question is the slant height of a frustum of a cone. Slant height of a frustum of a cone. Slant height means this side is 4 centimeter and the perimeter of the circumferences of the circular ends. So the perimeter of this given. So this is a circle. What is the perimeter of a circle? 2 pi r. 2 pi r is given as 18 centimeter and the other side perimeter it is given as 6 centimeter. Getting, they have given the perimeter of the circular ends. So from this we can find r. So r is equal to 18 by 2 pi and here r1 is equal to 6 by 2 pi. Okay, so which is equal to 9 by pi and here it is equal to 3 by pi. So what is the question? What is the curved surface area of the frustum? So you have to use the formula for CSA. CSA is curved surface area, only this surface area. Okay, so pi into r1 plus r2 into L, so which is equal to 22 by 7 into what is r1, that is 1 of the r. Okay, so into 9 by pi plus 3 by pi into what is L. L is given 4. So for pi here we have to substitute 22 by 7. Substitute this value and see. This is coming to 22 by 7 and then this 9 by pi is coming to 21 by 22 because it is 22 by 7 and 7 will go up and 7 nines are 63 by 22. This will come 63 by 22 and here this will come 21 by 22 into 4. Okay, so just substitute pi is equal to 22 by 7 and you are arriving at this 2. Okay, so into 4, this after calculation, this is you are getting as 48 centimeter square. Please do the calculation by yourself. As nothing, this is a common one. Then 22 by 7 into this 22 will be here 484 into 4, like this you will get and you cancel whatever you want. So then you will arrive at this 48 centimeter square. Why centimeter square? We are finding out the CSA. It's not volume. Yes, next question. FS. This is nothing, the name of the cap, that's it. Turks use. So don't get confused. This is, of course, it is shaped in the form of a frustum. That's it for our question. And if the radius of open side is, so cap one side should be open, no? So open side is 10 centimeter. Radius at the upper base, this side is 4 centimeter and its slant height L is given 15 centimeter. L is equal to, so find the area of the material used for making it. So area of the material means all the sides should be covered. That means what is the question asked is total surface area. So total surface area is, okay, so you have to find what you have to find. You have to find the total surface area. So pi L into R1 plus R2 is CSA plus, now we need the top only. Here now bottom is open, so no need to consider that. Only we need the top of that. So only 1 pi r square. Okay, R1 square. So getting or not? So this is the cloth required to make that. When there is open here, there is no need of any cloth over here. So we are leaving the bottom area and only considering the CSA curved surface area and the top top one. Okay, so only 1 pi r square here, only for the top area. Okay, so now pi L, so pi will be can be taken common outside. L is given 15 centimeter, and then what is given? R1 is given 4 and R2 is also given 10. Okay, so then plus here R1 square, top area we are considering, that area is 4 square. So here pi into 15 into 14 plus 16. Okay, so this pi is nothing but 22 by 7 into 15 into 14. Then we can cancel this 2 plus 16. So do the calculation. You are arriving at 660 plus 50.29. So that means 710.29 centimeter square. The sums are very easy. Only thing is you have to remember the formula and apply it properly. Also you should focus whether radius is given, slant height is given, or diameter is given, whether the units are changed or all units are same or not. Only these things you have to concentrate. And another one is, you don't do the calculation separately always. You take a common thing outside, then you do the calculation, so that many things can get cancelled and your calculation will be simple. That's it you have to notice in this. Other things are very easy. Okay. So the fourth question is, a container opened from the top and made up of a metal sheet is in the form of, the container is open at the top, there is no area over here. Okay, is in the shape of a frustum of a cone of height 16 centimeter with radii of its lower and upper ends. Smaller end will be 8 centimeter and the upper end is 20 centimeter. Find the cost of the milk which can be fill the container. Okay, so the container is filled with milk. 1 liter cost is 20 rupees. Okay, so first what we have to find? We have to find how much the container can hold. That is the volume of the container. Okay, so volume of the container means the formula for the volume of frustum, because the container is in the shape of frustum. So 1 by 3 pi h r1 square plus r2 square plus r1 into r2. Okay, just substitute this value, 1 by 3 into 22 by 7 into what is h, 16, r1 square is 8 square plus 20 square plus 8 into 20. So this is the volume of the total volume of this container. That means that much milk will be there in this. Okay, so when you do the calculation, you please do the calculation by yourself, because it will consume more time for me if I do the calculation. Okay, just I will give you the hint. 22 by 7 into 16 into this comes to around 624. So you can cancel as much as you can. So this getting cancelled as 208. So if you cancel, you are getting 73216 by 7. So which is nothing but 10459 centimeter cube. So okay, the volume you are getting in centimeter cube, but this you have to compare with the thing given as liter. So let us consider this centimeter, let us convert this centimeter cube to liters. Okay, so what is the conversion? 1000 cubic centimeter is equal to 1 liter. So 1 cubic centimeter is nothing but centimeter cube, is equal to 1 by 1000 of a liter. So how many cubic centimeter we have? This much. So this, if you are converting, then we have to divide by 1000. So what will be the answer here? It is 10.459 liters. What is this? This is the total volume of this frustum. Okay, that much of milk, 10.5, around 10.5 liters of milk is there in this. So now 1 liter of milk costs 20 rupees. So what is given? 1 liter milk cost rupees 20. So how much we have? We have 10.459 liters. So how much will be the cost? Cost will be 10.46, will approximate into 20. So which is equal to rupees 209. Okay. Now this part is done. What is the next question? Something else is also asked. Find the cost of the milk which can completely fill the container at the rate of 20 per liter. This we have found. This is rupees 209. Okay. So then find the cost of the metal sheet used to make the container if it costs 8 per 100 centimeter square. That is rupees 8 for 100 centimeter square. Okay. It costs rupees 8 for 100 centimeter square. That means what is asked? To make the container. To make the container, how much cost we require. So for that, first we have to find the how much area we require. That is CSA of the container we have to find. CSA is nothing but pi into R1 plus R2 into L plus only 1 pi r square. Why? Because the container is open at the top, only the bottom area should be considered. CSA is the curved surface area. Okay. So curved surface area plus only one area of the bottom. So if you calculate this, this is the metal sheet required to make the container. Okay. See, the container is made from some metal. That area if you find out, then only we can calculate the cost required to make that container. Okay. So now here again pi we can take it outside. So what is R1 and R2? 20 and 8. So 20 plus 8 into L is given or not? No, it's not given. Okay. So we have to find out L. Then plus here, which R square is this? R, we should not take it as R. We should take it as R1 because this is the bottom one. Bottom one is 8. So 8 square. Okay. So if this is done, then we can calculate. But here for this we need another data which is L. Okay. So first we find out L here. L for this and then we can substitute here. So what is the formula for finding out L? Slant height. L is equal to square root of h square plus R1 minus R2 whole square. So what is h? H given? S given 16. So h square is 16 square plus R1 minus R2. It's 20 minus 8 whole square. So which is equal to 256 plus 144, which is equal to 400 and which is equal to 20. So we have found L and let us substitute here in the place of L. Okay. So 22 by 7 here. Okay. Please do the calculation by yourself again and again saying, see, because it's nothing, it's not difficult task. Only thing is you have to understand what is asked and what formula you have to apply and what you have to find out. So if you do the calculation, you are getting 1959.36 centimeter square. Still the sum is not over. This is what? This is the surface area. So what we have got? Question what is given? 8 rupees for 100 centimeter square. See, 100 centimeter square cost is rupees 8. So 1 centimeter square cost is 8 by 100. Okay, now how much centimeter square we require? 15936 centimeter square. So how much does this cost? This is equal to into 36 into 8 by 100. So 19.5936 into 8. So this value comes to 156.75 centimeter, sorry, rupees. This is rupees. Okay. Getting or not? See, I will revise this question again. So container is given, milk container. This you can imagine. The radius of the bottom is also given. The radius of the top is also given. Height is given. So question is, we have to find 1 liter milk cost is 20 rupees. So how much value of milk can be filled in this container? So first for that we have to find the volume of the container and we found that 10.459 liters can be filled in this. So if this much liter is filled, 1 liter cost is 20 rupees. So for this much liters, what is the cost? That is done first part. Second part is metal sheet is used to make the container. We have to find the cost for that. So the metal sheet is, the top of the part is open, so only the bottom is closed. So the total area required is curved surface area plus bottom area. So that we have to find out. So while finding out, we see that L is not given. So we have to find out L and substitute there. So after substituting, we are getting some centimeter square. What is this? This is the total area to remake the container. Okay, this is done. Now what is other given? 108 rupees for 100 centimeter square. So 100 centimeter square, if you want, we have to pay 8 rupees. So we have this much of centimeter square to be made, this much of metal area. So what we have to do, we have to multiply by 8 by 100. 1 centimeter square cost is 8 by 100. So this much square centimeter cost is this into 8 by 100. So we will get the rupees required to make that container. Okay. Yes. The last question. Metallic right circular cone 20 centimeter high and whose vertical angle. Okay. Now we have getting into metallic right circular cone. This is not a frustrum. So please listen the question properly. Don't think it is a frustrum exercise. So we will make a frustrum. Right circular cone 20 centimeter high and whose vertical angle is 60 degree is cut into two parts at the middle. Now it is being cut to make a frustrum. Okay, it cut into two parts at the middle of its height, half of its height. Okay, then by a plane parallel to its base, like this. If a frustrum so obtained can be drawn into a wire of diameter 1 by 16 centimeter. Find the length of this wire. Okay, see the question one by one. Let us solve this. Okay, so the vertical angle means this whole angle is 60 and this angle is 30. Okay, so why this angle is given? Using this angle you can find the radius. Okay, so if you are giving, see, this is a triangle, this angle is given 30 degree and this height is given, and this is tan theta is opposite by adjacent. So this is the opposite and this is the adjacent. This is theta. If you are finding out tan 30, what is the opposite side? Suppose if I am taking this as x, then opposite side is x, and what is the adjacent side length? 20. So x is equal to, tan 30 value is 1 by root 3 is equal to x by 20. So x is equal to 20 by root 3. So what is this? This is the radius. Getting derive one by one. See, the cone vertical angle is given 60 degree. So this is the right circular cone. So the half of the angle will be 30 degree. And using that 30, why it is given, we can find out the radius of the cone because it's not given. So the radius we have arrived at 20 by root 3. Okay, so this is 20 by root 3. It is cut in the middle. It is told that cone is cut in the middle. So this height is 20 centimeter, means this frustrum height will be 10 centimeter. Okay, this is done. Now what is given? If the frustrum, this frustrum is drawn into a wire, that means it is melted or whatever it is done, it is drawn into a wire, and the diameter of that wire is 1 by 16 centimeter. So now we have to find the length of the wire. Okay, so what is asked? First, what we have to find? This has got some volume because this is having a diameter. So this wire has got some volume, and this frustrum has got some volume. Okay, so now we have to find the volume of this frustrum. So volume of the frustrum is, see here, this is drawn into this. This is like converting one shape into another. and both the volume should be same. This we have seen in previous exercise. Okay, so I'll do this in the next page. See here, volume of the frustum should be equal to what? The frustum is drawn into a wire. Wire is not wire but having a diameter. So wire having a diameter will be like this. What is the shape then? This is the shape of a cylinder. 1/16, it is very small thickness, but still it will be looking like a cylinder. So volume of frustum should be equal to the volume of the cylinder. This is nothing but the wire drawn. Okay, so volume of the frustum is 1/3 pi h r1 square, okay, r square plus r into r. Volume of the cylinder is pi r square h. Okay, so just substitute, we can cancel pi on both sides. 1/3, what is h? 10, and then what is r square plus r square? So this r is 20/√3. Okay, yeah, 20/√3. Another is 10√3/3. This is 20/√3, and this is cut in half, so it is 10/√3 plus 20/√3 into 10/√3. Okay, then this side, this r is 1/16, the thickness is, the diameter is 1/16, so the radius will become, see here, the diameter is given here, please note, diameter is 1/16, the radius will become 1/32, the whole square, into this height. This height we don't know. This height is nothing but length. Okay, this is what is asked now. Cylinder height, that is the question, is length. Okay, so we can take it as L also. L, this is nothing but height of the cylinder. As it is a wire, this is considered as the length. Okay, so now you have to do the calculation, and after doing the calculation you are getting 7,000/9 this side, and here it is 1/1024 into L. So from this we have to calculate L, which is equal to 7,000 into 1024 divided by 9. Okay, so there, from this we can find L is equal to 796,444.44 centimeter. Okay, if you require, you can convert into meter by dividing it by 100. Okay, so this is done. Yes, now see, I'll explain you this again. Vertical angle is given, so half of, since it is a right circular cone, then half of the angle will be 30. Using that half angle 30, we can find out a radius of this. So this is cut here. Okay, 50, that is, this is 10 and this is 10, like that they are cutting in the middle. So this height is 10. Again, this radius, how you can find? Again, this will be small like this, right? See here, this cut area, I'm saying, I'm speaking about this cut area. So this cut area will be like this. The angle will be 30. Its height will be 10 because it is cut at half. And this radius we can find it out. Tan 30 is equal to, this is R1. So R1 by 10. Okay. So then here 1/√3, and this radius will become 10/√3. Getting or not? Same method we are finding both the radius. So this is also 30. So that using that we can find the big triangle radius, and this is again 30, and using that we can find the small triangle radius. So this radius will become 10/√3 and this will become 20/√3. Okay, so now this wire, this cylinder, this frustrum is made into a thin wire. Since it's having a diameter, it will be like a shape of a cylinder. Okay, so the length of the wire is asked. So the length is nothing but the height of the cylinder. So one shape it is converted into another shape, then the volume of the first shape should be equal to the volume of the second shape. So we are finding out the volume of frustrum should be equal to the volume of the cylinder, that is nothing but the wire. So wire has some diameter, so it is a cylinder. Okay, so when you calculate these things, we get into the length of the wire. Getting? Okay, any doubt please mention. With this exercise is over. Thanks for watching.